section 12.1, extra example number 1. Does seat location matter? So here is a scatter plot, and the rows are basically, it appears as you sit further away that your score on the test decreases. Does this, so let's interpret the slope first. What is the slope? Good. Negative 1.12. So we need to interpret that in context. So what does that mean? For each what? So you don't want to say for each like change of 1 in x. There's no context. So for each what? Yeah, sure. Yeah, good. For each one row further back, what happens? What does that slope mean? The what? Okay, so be sure you use the word predicted when you're talking about something from a regression line. Okay, you'll lose points if you don't. So the predicted score will what? Decrease by, and don't just say by 1.12 because that doesn't have context. By 1.12 what? Points, right? Okay, so now we need to explain why the random part is so important. So why do we need to be careful about this condition? Why is randomly assigning these seeds so important? Yeah. Okay. Exactly. If we can't really predict anything, this wouldn't be a valid experiment if we didn't have the randomness, because maybe the more studious students will automatically sit in the closer row. And then we can't really say anything about the row's effect on your score, right? So if the students choose where to sit themselves, then we can't really make any inferences here, or establish cause and effect. So we need the average ability level to be the same at each row. We need average ability level to be same in each row. Otherwise, we can't establish cause and effect between row assignment and test score. So I would say something like that. Okay. Next is, so we're looking at, so this is our scatter plot again, just repeated from the other side. These are our residuals. This is a histogram of the residuals and a normal probability plot. So we're going to check the 5 conditions that are in your notes. Okay, so for linear, remember when you're remember DOFs? Like you doff your hat? So we need direction, form, strength, and outliers. This was from chapter 3, when we're looking at linear relationships. So how could we say that with the scatter plot? Shows what? What are the words that you need for full credit? The scatter plot shows what? Shows a. How about, let's start with direction. What's the direction? Negative. Thank you. we'll come back to outliers. What about the form of it? What's the shape, form? Linear. So a negative, and then, well, what about strength? Weak. So a negative, weak, linear relationship. The scatter plot shows a negative, weak, linear relationship. And the residual plot doesn't show any. There's random scatter with the residual plot, so that's a good sign as well. And it doesn't appear like there's any extreme outliers, so we're fine there. Independent, I just wrote in for you. It really only makes sense to do the 10% condition only makes sense if it's clear we're doing sampling without replacement. To do the 10% condition, otherwise you want the trials to be independent of each other. I actually watched a video over break of the author of your textbook going over one of the previous exams, and they said that actually you don't need to verify the independent condition unless they specifically ask you. So I'm going to not worry about it. So that's that. Normal. So if you look at the, this is the, if you look at the residuals, the histogram, right? It's roughly, has a roughly normal shape. So you can do, you can show it that way. The histogram of residuals has approximately normal shape. And I'll also say the normal probability plot is linear. So it's not like, so this is the number of standard deviations away from the mean, and it's not like you're getting further and further away, so that is a good sign. And then equal variance is, if you look for each x value, each row, the amount of variation in the y direction is roughly the same. It's not like they're getting further and further away. So that's the equal variance condition. So I'd say for each x, the variability of y is roughly the same. The variability of y is roughly the same. And then the random condition I just wrote in for you. The students were assigned at random. So since those conditions have been met, we can do a confidence interval for this one. But so let's look at, this is the data output, which is often what you'll be looking at in the last free response question. You get 25 minutes to do, and it's worth a lot of your free response, and you almost always you're looking at this kind of output, and we'll practice more together soon. So when you're looking at this, you want to just pick out the things that are important. So the things that are important are, when you see the word constant, look on the column for coefficient. Wherever you see the word constant, that's going to be your y-intercept in your equation, and the other is going to be your slope. So these two values tell you the equation of the regression line. So y hat is 85.706 minus the slope 1.1171x. That's the equation. So you tell me, what does y hat stand for? Predict. Very good. Got to use that word, predicted score. It is this is not the actual, it's predicted, and x equals the row number. Good. So we already did this. We interpreted the slope. See previous. What does the y-intercept mean in this question? Yeah. if you sat, the y-intercept means if you sat at row 0. There is no row 0. So row 0 does not have a meaning in this context. Row 0 does not have meaning in this context, and so you would not extrapolate, to use that word, but it's more important that you understand the concept than the word that goes with it. So you would not extrapolate to 0 on that. Standard deviation of the residuals. This is a really important value. Where is it above? Standard deviation of the residuals. Which number do you think that is? Do you see it anywhere? Yes, this is the standard deviation of the residuals. That's really important. That tells us about how far off we're going to be when we use our least squared regression line. So so when we use the, you can abbreviate least squared regression line to predict the test score from a student's row number. I'm going to write it all out. To predict, because sometimes the whole question will be just to interpret this. When we use it to predict a test score from a student's row number, we will be off by about, which is like a whole letter grade, by about 10.07 points on average. Approximately. Use those words, on average, approximately. Okay, so and now we're going to the standard error of the slope. So how much will our slope be off by on average, and where is that given? You're not going to have to compute it. It's going to be given somewhere. Where do you think that is? SE coefficient, which one? Yep, it's right here. The one for slope. It's on the same row as the slope. Okay. 0.9472. So if we repeated this experiment many times, the slope would vary by about that much from the true slope. So if we repeated experiment and came up with our regression line, repeated experiment, our slope would typically vary about 0.9472 from slope of true regression line, meaning population regression line, true regression line. Okay, now we're going to calculate our interval. So look at the formula there on the back. We would do our equation, where did I put it? Is, oh. So we would do what we got from our trial here. We would use, we want to know, so negative 1.1171 is a estimate of what our true population slope is. That's what we got in our experiment, right? But then we're going to go above and below a certain amount, above and below a certain amount to get the 95% confidence interval. So how much above and below? Well, we're going to use the standard error of the slope. So that's like the standard deviation that we've been using before. And then to tell how many above and below for 95% confidence, we just use inverse t. So to get t star, we just do inverse t, and you tell me, what do I put for a 95% confidence interval is how much on each side? 2.5% on each side, so 0.025. For degrees of freedom, you're going to use n minus 2. And so that would be what? How many students? So our sample size is 30, so n minus 2 is... Okay, so if you do that on your calculator, inverse t, you'll get t star of 2.048. And so that's our confidence interval, and so the answer would be between negative 3.057 and 0.8228. So could our actual slope potentially be 0?
Yes.
Yes. So since 0 is plausible, we cannot say that there is a association between test score and row number. So so I will say because our interval contains slope equal to 0, we do not have convincing evidence there is an association between test score and row number. In our interpreting the interval, we would say we are 95% confident that the interval from -3 to 0.8 captures the slope of the true regression line, relating a student's test score to the student's row number.